Okay, so today we're going to solve exercise 13 from paper 1-2 from the exam May 2021 of the AS level Cambridge physics. So this exercise is a bit different from what you normally get. It's as in many exercises in Cambridge, the main difficulty is to understand exactly what is going on. So we have a square sine of weight 40 newtons, which is suspended vertically from its top edge by a horizontal hinge, as shown. Okay, so then the hinge is not frictionless, so we have friction. When the sine is displaced from the vertical by an external force and then released, it does not return to the vertical position. So basically, we have displaced it, released it, and it stays. It doesn't go back to the vertical position. So the maximum torque exerted by the hinge on the sine is 6 newtons per times newton meter. The sine is displaced by 90 degrees, so that it's horizontal and then gradually released. At which angle to the vertical does the sine hang after release? So as I said, the first thing is to understand what is going on. We have displaced the sine from the vertical and we have set it horizontal. And then we have released it, and it's going to go down by its weight, turn down by its weight this way, and it's going to stay in a position which is not, it doesn't go back to the vertical, so it's going to stay in this position. Okay. So why is this? Well, we have a force, a weight here making it going downwards, but we have a friction of the hinge which is forcing it upwards, and so that there right now it's in equilibrium and it stays there. Remember that to be in equilibrium we have two options. We have either the sum of forces equals 0, which when something is turning it's not very easily calculated, but we can do the sum of momentum equals 0, and that basically means that the moment clockwise equals the moment anti-clockwise. Okay, so there's a force here causing a clockwise moment, which is the weight, and there's a force here causing the anti-clockwise moment, which is the friction. One of the most difficult things to understand here in this exercise is that the torque exerted by the hinge is 6 Newton meters, so that is the momentum by the exerted by the friction. Okay, so the moment anti-clockwise is going to be 6 Newton meter. Okay, and what is the moment clockwise? Well, the moment clockwise is the force times the distance. But remember that in the formula, moment equals force times distance. Both of these have to be perpendicular. So in this case, what we're going to do is we're going to calculate the perpendicular component of the force, which is Fy, and Fy, this angle is going to be the same as this angle, and they've said that, and that's the angle that they're looking for. Okay, so Fy is F sine of theta. Okay, and the distance is going to be this distance over here, which if we suppose that it's a uniform sine, we can consider that the mass is in the middle, so the distance would be half of its length. Its length is 0.8, so we consider that this is 0.4. Okay, so the clockwise momentum is going to be F sine of theta times 0.4. Okay, so in order to be in equilibrium, when it stays there, both have to be the same. So F sine of theta, F is the weight, times 0.4 equals 6. The weight is going to be 40 newtons, so we have 40 sine of theta times 0.4 equals 6. So sine of theta equals 6 divided by 40 times 0.4, and theta is going to be arc sine, or sine to the power minus 1 of 6 divided by 40 times 0.4. And if we do that in the calculator, we get 22.02 degrees, which is what answer B, and that's the one that they give us in the marking scheme. So that's correct. Okay.